Okay, so recap. In this situation, what does F stand for? Find. What about W? When. G. Given. And E is equation. If you're not on this page, just turn the page to October 8th, today. Okay, so Fuigi, this is going to be our framework, okay? All right, so we have a kite flying horizontally with a speed of 7 meters per second at an altitude of 30 meters. Determine how fast the length of the string is increasing when the kite is 50 meters from the kite flyer. Okay, so again, this is not something you read and you just say, the answer is 2. Okay, nobody does that. Now, a picture is actually going to be really helpful here. Do you have a picture in your mind of what this looks like? A right triangle, and here is your hint right here, right? So, so let's draw a right triangle, and let's go ahead and even put the kite on there. And then here's the kite. It looks like a jellyfish, really, but here's my kite flyer. And in my picture, I'm going to go ahead and let you in on a secret. I am going to let A be the altitude, B be the base, and the hypotenuse is C. What are you already thinking of? Pythagorean theorem, hopefully. Okay, so let's see what I can easily put on my picture. And the rest I'll put on my Fuigi. So the speed, I can't really put that on the picture. But the altitude of 30, I can put right there. 30 meters. What else could I easily put on the picture? 50 meters. Which one is that? Yeah, it's the distance between the kite and the person, so 50 meters. Now, if you're really good at geometry or you just remember your Pythagorean triple, finding the third side is super easy. 40. Now, if you forgot your Pythagorean triples, meaning like 3, 4, 5, 5, 12, 13, and so on, you're going to have to go off to the side and do Pythagorean theorem, okay? I'm not going to show that right now. So let's finish out our Fuigi. Okay, what are we trying to find here? Determine, that's the same as F, find the speed of something. So again, I know that that's going to be a d over dt. D what? A, B, or C? If it's determine the length of the string is increasing. C. Okay? The when is everything you put in your picture. So I'm just going to write the word pick. And that means my when is all this stuff. Okay, given is anything else I haven't written down. So this is where I'm going to get to my 7 meters per second. Now we did this yesterday, but let me reinforce this. Look at the units. See how the units are per? That is a derivative. Now you're just trying to figure out, well, which derivative? If a kite is moving horizontally, is that A or B?
It's A.
Horizontally would be dB over dt, right? Now, we're going to assume that the kite is moving away. I write an arrow here, away from the kite flyer, okay? So dB, B is getting bigger, so dB should be positive. Now, you may have already just assumed that, and that worked out fine in this case. Okay, if B was getting smaller, then this would need to be a negative speed. You know how like when you're driving in a car or you're like in physics, you're going in opposite direction, that's a negative velocity? It's the same situation here. All right, now you already told me what's the equation. What are you thinking about with A, B, and C? A squared plus B squared equals C squared. Okay, so I'm going to rewrite it over here. A squared plus B squared equals C squared. Now, we haven't taken the derivative of Pythagorean theorem, but it's the first time for everything, right? So I'm going to go ahead and take d over dt of both sides. So what do you think the derivative of a squared is? 2a dA over dt. Okay, b squared would be 2b dB over dt. C squared is going to be 2c over 2c dc over dt. All right. After we derive, what do we do now?
Plug in.
We plug in what we know and we find out what we don't know. Okay, A. Just look over here at the picture. That's 30. This is why the picture really helps here. dA over dt? Ooh, they don't give us that. So what do you guys think? Did we mess up? So what is dA over dt representing? How fast what is changing? A. Is there anything in this problem that tells us that A is changing? In fact, I think I can assume that if they say the kite is moving horizontally, that it's not moving vertically. So this is actually 0. And when you do these problems on these right triangles, a lot of times, one of these is going to be 0. So let me repeat this, because I know some of you didn't catch it. I'm going to use different words. When you're trying to find one of your derivatives and you can't find it, it could be that it's 0. Look at the problem and say, is A actually even changing?
Is this only for right triangles?
It really works for any problem, but it's most important for right triangles. A is not changing. Now, in a minute, we're going to talk about a kite falling vertically. That's going to be what dA over dt is. So don't make the problem more complicated. Don't say, well, what if A is changing? No, if they don't tell you it is, it's not. Okay? So let's continue with this. 2b, that's 40. dB over dt, that was our given, that's 7. I'm going to have to start writing smaller. And then C is 50. And then dC over dt is what we're looking for. All right, now, you guys know enough algebra at this point to solve for dC over dt. So I want you to do this now. Get dC over dt by itself. Use your calculator, use the solve feature on your calculator. Just multiply the numbers and subtract and divide and all that. If you don't have your calculator, you could use your phone, because this is just like simple adding, subtracting, multiplying, dividing. When you got it, shout it out. Keep in mind, with the 0 term, you can just cross that off. So you're just multiplying these numbers, divide over 100, you should get 5.6. Okay, I'm going to move on. If you're having trouble with this, ask me later. All right, so look at the next one. The problem, everybody look up here. The problem is the exact same problem. The only difference is that we have this added element of a kite falling vertically. So in other words, it's all the same thing. They're still telling us to find, they're going to explain it differently, determine the speed at which the string is being paid out. That's still dC over dt. The when, the given, those are all the same, okay? Except that they're also given that dA over dt is how much? 5 meters per second, except one tiny little thing. It's your nose. That was funny. So if A is going, in this case, look up here at our picture. If A is going down, A is getting smaller.
-5.
So dA over dt should be -5. That's easy to miss, and we just started doing this, so that's something we're going to have to watch out for. All right, I am going to go through the steps again. I'm going to go through them a little bit faster this time. So again, we have a squared plus b squared equals c squared. Again, I'm going to take the derivative with respect to t. We get 2a dA over dt. I mean, it's the same thing. I could have just picked up where I left off, but this is good practice. dB over dt equals dc over dc over dt. Okay, A, just looking right up here, 30, or you could look at this right here. But now dA over dt is something that we're given. 2 times 40. This is all from the picture or from Puigi. So I want you to do the calculation again to find dc over dt. I know this isn't the easiest thing in the world, but it will get easier, but you have to practice it. So just let that be encouraging to you as we go. Just keep practicing. What are you guys getting? 2.6 is correct. If you snuck a peek, sneak the peek. I don't know what's the right way to say that. You saw I already had it up here. Alright, let's move on to a different type of problem. Alright, so here we got a ladder. A ladder leaning against a house. You guys know what this looks like. It looks like a right triangle. You've seen this picture before, and you can even kind of make it really even look like a ladder. And guess what I'm going to name the sides of my triangle?
A, B, C.
A, B, and C. A for altitude, B for base, C for hypotenuse. All right, let's see how much I can label on the triangle before we really get to Puigi. So 13-foot ladder. Can I put that on my triangle? Which side? The hypotenuse, 13. Okay. Base of the ladder is 5 feet from the base of the house. There's a lot of base. 5. Sorry. Okay, this I can't put on there. What's A? 12. That's another Pythagorean triple. To your advantage if you just know these. It's just more work if you have to go off to the side and do it and do Pythagorean there. Okay, so what are we trying to find in part A?
How fast the top of the ladder is.
Yeah, so let's translate that into math. How fast, that's a derivative. Derivative of what?
Velocity.
Okay, when you decide what goes here, it's going to be A, B, or C.
Oh.
Because the derivative in, okay, so the question was like velocity. D whatever over dt is the velocity. So so it says how fast, that's my derivative word, is the top of the ladder moving. In other words, this ladder is going to slide down, so dA. So notice when I put it on the picture, it became more obvious. So you use the picture to help you. Okay, the when is everything in the picture. What about the given? Is there anything we haven't written down yet? 3 feet per second. Okay, and we got to think, is that dA or dB over dt? Which one? So the base of the house is moving, so dB over dt. So it's 3, right? I kind of erased it on accident, or wrote over it. But that's 3. Is it positive or negative 3? I see the word away, which makes me think negative, but keep in mind, this is moving away. So is B increasing or decreasing? It's increasing. So the derivative should be positive. And it is, and that's the way we wrote it. Okay, our equation, again, is going to be Pythagorean theorem. So, again, I'm going to go through this part quickly. We already did it.
Let's get our quiz on Friday.
This could definitely be on your quiz on Friday. Anything I go over and do tomorrow, though, won't be. So here we have 2a dA over dt plus 2b dB over dt equals 2c dC over dt. Okay, same thing we got every other time we derived Pythagorean theorem. So let's start plugging in what we know. We know that a is 12. We know that dA over dt is what I'm looking for, so I'm just going to rewrite it. We know that b is 5. We know that dB over dt, that was our given, that's 3. We know that c is 13, and oops, I don't know dC over dt, so probably it is 0. Now, why, like logically, is dC over dt 0?
The length of the ladder can't change.
The ladder is not increasing or decreasing. Okay, you know those extendable ladders? This is not one of them, and I'm glad. I don't want to do that problem. So we're going to say it's just a regular old ladder. It's not changing. All right, so what you got to do here is you got to solve for dA over dt. Okay, I'm going to go ahead and tell you, you get negative 5/4. What are going to be the units? Feet per second, right? I know I'm going through that part fast so that I have more time to explain everything else. Okay, so let's look at part B. Same situation, except here the find is different. It says determine, find, the rate. So I'm still doing a derivative of something with respect to t. Okay, of the area. Now don't freak out on me, guys. I'm going to use capital A for area. It's not the same as little a. They're different A's. Okay, if you want, choose a different letter instead of A for area. Okay, everything else is the same. Your W and your G, those are the same. My equation, though, is different. What's my equation?
AB over 2.
Okay, are you okay if I write it as 1/2 AB? This is going to be more helpful for my purposes because what I have to do now is take the derivative of both sides. That gives me dA, big A, over dt. And what rule am I going to have to use to take the derivative of 1/2 A times B? Product. You can groan, but just keep working. You can groan and whine all you want, but keep working. So, 1/2 dA over dt, that's the derivative of the first part, times just the second part, plus, you know it, what's next?
1/2 A
Mm-hmm.
times 2. dB.
Exactly. Good. You can write the 1 if you want. That's fine. But you still got to write the dB over dt.
Okay, I get it now.
I've kind of dropped writing a lot of the time ones, but you could if you wanted to. There's nothing wrong with that. All right, let's plug in. So I'm going to have to maybe right over here. All right, I got a 1/2 dA over dt. That's what I just found right here. That's negative 5/4. B was 5. I'm just looking at that back at the picture. 1/2. A was 12. Oh, I got to write really tiny over here. dB over dt, that was 3. That was my original given. So just plug that in your calculator. If my memory serves well, I'm pretty sure this is 14.875. Somebody confirm it. What are going to be the units if it's area per time? What are my units? Feet what? if it's area per time. Feet squared per second. I know, it's the end of the day. We're getting tired.
Wait, what was our answer?
14.875 feet squared per second. Square feet per second. You're just multiplying all that out in your calculator. All right, I want y'all to do me a favor, and I want you to just like put your calculator down and focus on this last part. You can always go back and make sure that you can get that answer. So for the last one, it says find. Again, we have a different f. The rate, that's my derivative word. So I'm going to go ahead and go d over dt, at which the angle between the ladder and the ground is changing. Theta, exactly. We're going to use theta. You don't like theta? Use x. I don't care. I am going to use theta. Now watch, I'm going to have to use like a different, okay, look, this is my theta right here, okay? That's horrible. I did not mean that.
Minus theta, we can use x.
You can use whatever letter you want. Doesn't matter to me. Okay, I'm going to use theta because I want y'all to get used to seeing theta. Okay, so we've got to, W and G are going to be the same, but we've got to come up with an equation. And this is where we're going to have to use trig. Okay, so we can use sine, cosine, or tangent. Which one of those do you think is easiest?
Sine.
Okay, sure.
Sine of theta.
Sine of theta equals A over C. Don't put the numbers in yet. We got that from SOHCAHTOA, okay? SOHCAHTOA. Opposite over hypotenuse. All right, now I'm going to rewrite it over here. I don't want y'all to get so overwhelmed with all the little details that you miss what we're doing. We're just coming up with an equation so that relates back to what we're trying to find. And so now I got to take the derivative. Now remember, we're always taking the derivative with respect to time. So what's the derivative of sine theta? Cosine theta times what? D theta over dt. Always d whatever the variable is over dt. That's the same no matter what we're doing. What am I going to have to do to derive a divided by c? What rule? Again, you can groan and whine all you want. I understand, but let's keep going. So, derivative of a would be dA over dt. You can write 1 times if you want. Then we just multiply by the denominator. Minus. Now, we just write the numerator times the derivative of the denominator. All over the denominator squared. So it wasn't that bad to do a quotient rule in the middle of that. But this is why I wanted you guys to be really good at all derivatives before we did this. All right, cosine theta. Go back up to your picture and tell me, what is the ratio for cosine theta? And this would be SOHCAH, C-A-H. So adjacent over hypotenuse. In this problem, 5/13. You want me to repeat how I got that? All right, I'm going to take that as a no. D theta over dt. That's what we're trying to find, right? So I'm going to leave it as d theta over dt. dA over dt, little a anyway, is, if I go back up, that's what I found here. So that's going to be negative 5/4 times c, that was 13. We are about to catch a break here because what's dc over dt? 0 over 13 squared. Do what you need to do in your calculator. Okay, you will get negative 1/4. Now, for theta, you might be tempted to write degrees, but in this class in calculus, we're never in degrees. What are we always in? Radians. So I'm going to write radians per, and then our time on this whole problem has been in seconds. All right, so this stepped it up a little bit. We're going to practice right triangles some more tomorrow, okay? And then we're going to work on a cone problem. So tomorrow's going to be more about related rates. Okay, so don't shut down on me. Just keep trying, okay?